Welcome back to the part 2 in the module parametric and non-parametric testing of hypotheses for more than 2 groups. In this part, we are going to discuss testing the parametric hypothesis mostly with ANOVA. Analysis of variance there is of 3 categories: one way, two way and multi-way. What are the hypotheses for ANOVA? As I said, this hypothesis is parametric hypothesis. Moreover, the comparison is more than 1-2 means. Assume that there is a hypothesis where we have the comparison between k groups of independent variables. So, where mu is the average of dependent variable. Now, ANOVA, what it is saying that alternative hypothesis is not equal, null hypothesis is equal. So, equal hypothesis, what it is saying that there is no significant difference between the k means, k population means. So, this is the test for hypothesis. Let us consider this is the normal, there is one sample data. This is the students' marks which are there in a random sample. A random sample of the students of each row was taken. The score of those students on the second exam, that examination is called second examination, was recorded by a teacher. There are 3 rows: front row, middle row and back row. Front row has some students, their scores are given. Similarly, middle and back rows, their students' scores were given. Now, our interest is to test whether there is any significant difference between the average score of front row, average score of middle row and average score of back row as far as their averages are concerned. Now, if you see that it is called summary statistics. After making calculations to the given data, it is clear that the sample size, there are 7 observations, 7 students are in front row, 9 students in the middle row, 8 students in the back row. The averages are given and standard deviations are given, variances are also given. So, mu 1 is considered to be 75.71. Mu 1 means mu 1 estimated value. Similarly, mu 2 estimated value is 67.11 and mu 3 estimated value is 53.5. So, we want to check whether there is any significant difference between these two. Mathematically there is a difference, but whether the difference is statistically significant or not is our interest of study. So, coming to the prime sources of variations, there are the variation between the groups and variation within the group. What it means that front row, back row and middle row. Is there any difference between these rows in the sense that class has having that one? Similarly, within the row whether there is any significant difference, variation is there. That happening we use to test in the analysis of variance. One is between the groups and another is within the groups. So, an example, we have that grand mean means overall mean. There are 3 groups, x1 bar is first one, x2 bar is second one, x3 bar is the third one. Overall mean is 65.08. That means mean of the means is 65.08. Between the groups, if you want to calculate, it is usually denoted with SS, sum of squares, due to or between the groups is denoted with SSB, and this is calculated, that is comes under 1902. And within the groups, if you calculated, it was given that 3386. If you put all the observations, the sum of squares between sum of squares is 1902 and within the sum of squares is 3386 and total is 5288. Now, coming to the degrees of freedom. Degrees of freedom is something like each value that can be vary before the rest of the values are predetermined. It is something like independent values for calculating the parameter, that is called degrees of freedom. The degrees of freedom often it is 1 less than the available number. So, between groups degrees of freedom is 1 less than the number of groups. We have 3 groups, therefore, degrees of freedom is 2, 3 minus 1 is 2. We have within the group the sum of individuals of each group, the sample sizes are 7, 9 and 8. So, within the group first sample the degrees of freedom is 7 minus 1, second one is 9 minus 1 and third one is 8 minus 1. So, finally, you can say that 7 minus 1 is 6, 9 minus 1 is 8, 8 minus 1 is 7, 6 plus 8 plus 7 together 28. That is the degrees of freedom within sum of squares. Total degrees of freedom is 1 less than the sample size. The sample size total is 24. So, you have to subtract one thing. So, degrees of freedom for total sum of square is 23, degrees of freedom for within groups sum of squares is 21 and sum of squares degrees of freedom for between sum of squares is 2. So, after putting that values, this is the table, improved table, this is called ANOVA table. Now, coming to the F statistic, it is something like ratio between mean sum of squares to the between and within. So, an F statistics is a ratio of 2 sample variances. MSB is mean sum of squares due to between groups, MSW means mean sum of squares within the group or 2 sample variances. So, F statistics is the ratio between MSB by MSW. So, for our data F will be 951.0 by 161.2 which is equal to 5.9. Finally, if you add that also mean sum of squares and together F statistic, this is the table. Now, coming to the p values, p value is something like a critical value. It is in our terminology probability of rejecting the null hypothesis when it is true. So, that p value is also considered as critical value. If that critical value is very small, then hypothesis will be accepted. If the critical value is very small, the hypothesis will null hypothesis will be rejected. If the hypothesis, if the critical value is very large, the null hypothesis will be accepted. So, that way you have to give the conclusion. See, the critical values is statistic value is 5.9 and p value is 0.009, it is less than 0.05. So, therefore, null hypothesis is rejected. What it means? The meaning is we have rejecting the null hypothesis. Finally, there is what is null hypothesis? There is no difference between the mean values, that is the null hypothesis. If it is rejected means there is a difference between the difference between them between the means is significant, that is the conclusion we have to make it. So, p value is useful for making conclusions. The post hoc analysis will be useful for extending the analysis, testing the significance among every pair of the group within the null hypothesis is rejected. So, this is intended to test the interaction effect of the 2 variables. Post hoc analysis is such a wonderful tool to explain the significance of difference between the means with a more meaningful way. So, with this the part 2 what we discussed is that I have given the explanation on how analysis of variance, one way analysis of variance is a parametric phenomenon in which we discussed one way, two-way analysis and further one way analysis brief description with an example we discussed. With this, I can say that this post hoc analysis is an extension study of any analysis of variance for one way classification. Thank you.